Welcome everyone. Today I'll walk you through radiographic testing, one of the most powerful NDT methods used in industrial inspection. Principles, applications, and inspection guidelines based on API 577 and ASME Section 5. We'll cover how it works, where and when it's applied, and the rules that guide its use. Please be informed, this summary is intended to simplify the content based on the presenter's interpretation. Radiographic examination or RT general overview. RT is a volumetric inspection method, meaning it checks the entire weld, not just the surface. It uses radiation, like X-rays or gamma rays, to detect flaws inside welds. Radiation passes through the metal and hits a film or digital detector, creating an image. Radiograph. Digital RT, filmless, is available but requires special equipment and trained personnel. RT is more expensive and regulated due to radiation safety concerns. Certified inspectors, minimum ASN Level 2, interpret the images to find defects. Safety training and compliance with regulations are mandatory for all RT personnel. ASME Section 5, Article 2 requirements. Radiographs must meet the following quality standards: detect backscatter radiation, include traceable identification, use approved film types, apply image quality indicators or IQIs, follow recommended techniques, have proper viewing facilities, ensure source calibration. Radiographs are acceptable if they show the required sensitivity and density, revealing flaws relative to the weld thickness. Image quality indicators or IQIs. IQIs, formerly called penetrometers, are tools used to verify the sensitivity of the radiographic technique. The purpose of IQIs are to ensure the radiograph can detect flaws of a certain size. And the IQIs must be visible on the final image to confirm quality. IQI selection criteria includes IQIs made from the same or similar material as the weld. And selection criteria based on weld thickness, excluding backing rings. Types of IQIs. Number 1 is wire-type IQIs, made of wires with different diameters, placed perpendicular to the weld. The smallest visible wire indicates sensitivity. The essential wire must be visible for the radiograph to be acceptable. Types of IQIs. Number 2 is hole-type IQIs, metal strips with holes of various diameters. Holes appear as dark spots on the radiograph. Hole sizes are multiples of the strip thickness, e.g., 1T, 2T, 4T, placed next to the weld on the base material, or a shim, for example, for a weld thickness of 0.312 inches. Or 7.9 mm, use a number 15 IQI with 0.015 inches. Thickness. Each IQI number corresponds to a specific thickness and required hole size. Radiographic film. Class 1 or 2 film is acceptable. Film must be large enough to cover 1 inch overlap between exposures, 3/4 inch coverage on each side of the weld. Store film in a cool, dry, clean area, away from heat, moisture, and radiation. Radiographic source selection. Common sources: iridium 192, for steel thickness 0.25 to 3.0 inches, cobalt 60, for steel thickness 1.5 to 7.0 inches. X-ray machines may also be used. The chosen source must provide adequate sensitivity for the material thickness. Film processing. Film can be processed manually or automatically. Typical development time: 5 to 8 minutes at 68 degrees Fahrenheit 20 degrees Celsius. Adjust time for different temperatures. Chemicals, developer, fixer, rinse, must be regularly changed to maintain quality. Radiographic techniques. Generally, best technique: radiation passes through one thickness of material, with film on the opposite side. IQI should be placed close to the weld. Technique must consider orientation of expected defects, especially tight planar flaws, which are harder to detect if not aligned with the radiation beam. Radiographic techniques. The first radiographic techniques is single wall technique. Radiation passes through one wall. Preferred method when possible. Multiple exposures may be needed to ensure full coverage. The second radiographic techniques is single wall viewing. Radiation passes through two walls, but only the film side wall is evaluated. Used for circumferential welds. Minimum of 3 exposures at 120 degrees intervals. The third radiographic techniques is double wall technique. used when single-wall technique is not practical. For pipes equal or less than 3.5 inches diameter, radiation passes through two walls, both viewed on the same film. Beam may be angled to avoid image overlap. Minimum of 2 exposures at 90 degrees or 3 exposures at 60 degrees or 120 degrees for full coverage. Evaluation of radiographs. Generally, radiograph evaluation is the final and critical step, requires skill and experience to interpret different weld defects, common defects, easy to detect, porosity, slag, inclusions, rounded shapes, harder to detect, cracks, lack of fusion, overlap, tight, linear, or angled flaws, orientation of defects affects visibility. Some may be missed if not aligned with the radiation beam. Viewing facilities must have controlled lighting to avoid glare or reflections. Light source should make IQI, penetrometer, clearly visible. Use low-power magnifiers, 1.5x to 3x, to help interpretation. Tools like comparators with etched scales help measure and magnify. Radiograph quality. Radiographs must be free of blemishes, mechanical, chemical, etc. In the area of interest, if blemishes interfere with interpretation, the radiograph must be redone. Area of interest. The part of the image that needs evaluation. ASTM E1316 defines it clearly. ASME Section 11 suggests using 1 ton, where T is the material thickness, as a guideline. Radiographic density. Density means how dark the film is after exposure. 0 is clear film. 1.0 is 10% light passes through. And 2.0 is 1%, 3.0 is 0.1%, and 4.0 is 0.01%, acceptable density ranges. For X-ray density range is between 1.8 and 4.0. And for gamma ray density range is between 2.0 and 4.0. Use a densitometer or step wedge to measure film darkness. Multiple readings should be taken in the area of interest or excluding defects. Density must stay within the specified range. Excessive backscatter. Backscatter is radiation bouncing back to the film, causing unwanted exposure. Use a lead letter B on the back of the film holder to detect backscatter. If a light B appears on a dark background, it means unacceptable or poor shielding. And if a dark B on a light background, it means acceptable. Misconception means, the B always appears. That's not true if there's no medium to cause backscatter. Interpretation. Interpretation is a subjective skill requiring knowledge of radiation sources and media, understanding of weld types and expected defects, awareness of how defect images vary with geometry, familiarity with acceptance criteria. Training is essential to improve consistency between interpreters. For critical applications, multiple qualified interpreters should review the radiographs. Radiographic examination records. Radiographic examination records must include, record job details, such as job or contract number or ID, record film and exposure info, includes, location of markers. Number of exposures taken. Type of radiation used, X-ray voltage or isotope. Focal spot size, X-ray, or source size, isotope. Film type and manufacturer. Number of films per cassette, record material and setup info, includes, type and thickness of base material and weld reinforcement. Distance from radiation source to object. Distance from object to film, record technique details such as single or double wall exposure. Single or double wall viewing. Type of IQI or penetrometer used and required hole or wire number. Record procedure and personnel info, includes, reference procedure or code. Examination results. Date of examination. Name and qualification of examiner, and record additional documentation, such as drawings, component IDs, and other relevant details must be included in the report and shared with the customer's representative. Thank you.